All right, everybody. So today we're going to be going through a tutorial on how to do multiple regression. We'll start off with simple regression and then being able to try and compare some models. So I'm going to see if I can do this in a bit of a speed session and get through all 4 programs as quickly as I can. So first thing I'm going to do is send myself down to the corner. And here we are in Excel. We're going to be using the file called recordsales.multi.csv. So make sure you download that, and this is what you should see. We've got sales, and then we've got a few different variables: adverts, airplay, and attractiveness of the band. We're going to see if we can do regression analysis to predict the amount of sales based on these other variables. So remember the first time when we did simple regression, we went up to the Data tab and over to Data Analysis. Click on that, and we're going to scroll down and we're going to select Regression. Hit OK, and it's going to ask us for our ranges. I'm going to input my Y range, that's my prediction, and it's sales here. I'm going to scroll down and just select all of those. Okay, and so the next variable I'm going to do is select my X range, and that is adverts. Remember, we had done that last time, so select all of that. Done. I'm going to say that my columns each have labels, and then output onto a new worksheet. Hit OK. Bam, here we go. We get our data, which gave us the same thing we saw before, which is basically our coefficients of 134.14. That's our record sales with 0 adverts, and then 0.096 increase in record sales. This is in the thousands for each advert increase. And we see that the F ratio for that is 99.5, and that's significant, 2.94 times 10 to the negative 19. Okay, great. So our next thing is, how do we do a multiple regression? Well, in Excel, it's actually really easy. So all we're going to do is go back to that first tab, and we're going to go back to the top, and I'm going to do regression analysis again. So click on Data Analysis, click on Regression, hit OK. It's still got input Y range from A1 to A201. That's fine. But now I want the input of the X range not to just be B, but I want B and C. So we'll just do in adverts and airplay. So I'm going to select here, and instead of all of those, I'm going to select the 2 columns now, all the way down to the bottom. Okay, and this time I'm going to do another new worksheet. Okay, now, again, you see we now have a new output. We see our R-square value is 0.629. If I go back to my first tab, my R-square was only 334. So it looks like we've explained a bunch more of the variance. Go back to sheet 2 here. We see that we now have a new set of coefficients. So first of all, we have a new intercept that's 41.12 thousand record sales with nothing. And then the increase with each ad is 0.08 thousand, and the increase with each airplay of the song is 3.58 thousand sales. Now what we see is we've got a F ratio of now 167.20 and significance of 3.55 times 10 to the negative 43, which is a ridiculously low p-value. Okay, so the question you might want to ask is, how do I know if my regression coefficients are better for the second model with the 2 predictors than it is with the first? Well, the simple answer is, in Excel, it's not that easy for us to be able to calculate that. Well, what you can do, if you want to compare models, is use this equation right here, where we see we get an F of the change in the R-square value, or in the R value. And the F value of the change we can then compare against an F value, an F table. So what we do is we see f change equals n. Here n is the number of subjects, and k in this case is the number of predictors in the model. So in this case, k of the new and k in the change. So how many have changed? All right, and the r square value of the change and the r square value of the new. But this is really a way you can do it if you want to in Excel. It's really not that easy. So, other than this, there isn't a whole lot we can do in Excel in terms of multiple regression. So some of the other things we're going to want to do, we'll look to use JASP, SPSS, and R. So let's move straight into using JASP to find out what we can do with the same file. So if I open up JASP and I look to open up record sales multi.csv, I'm going to open up that file, and then I'm going to change really quickly. We see that attractiveness here, that's actually a categorical variable right now. If I want to change that, all I do is I click on the little symbol beside the word attract, and I select that I want it to be a scalar variable instead. Okay, so the next thing we're going to do is run our regression analysis just by clicking on regression and linear regression. We decide what our dependent variable is, and that's sales. And now remember last time when we ran a simple regression, all we did is we put in adverts, and we got our regression equation, which gave us 134.14 and 0.96 as our beta coefficients. Now, simple enough, if we just want to run a multiple regression, all we do is we add extra variables. So I'm going to throw AirPlay into my variables here. And what we see is I get a new set of data down here. So I've got intercept, adverts, and AirPlay. So what that means is I'm getting different beta coefficients as I add in different variables. Now, the way we can do this is we can typically use an enter method, which forces all of the variables into the regression equation at once. We could use a stepwise forward or backward method, but we typically don't want to do that unless we've got a really, really good reason for doing that. Now, if we want to compare models, and if we want to see an output that looks very similar to what SPSS and R are going to give us, we're going to do a couple of different things. So the first thing is we're going to go down and click on the Statistics tab here, and I want to click on R squared change. And that will create a new sort of side over here, which gives me some values in terms of the R squared change, the F ratio of that R squared change, and then a p-value of that. The other thing we're going to do is click on Model. And what this will do is it allows us to look at the variables in a hierarchical way. So if I click on Adverts as including in adding to the null model, what this does is this gives us, if we look down here at our coefficients, now it gives us our coefficients as if adverts was the only thing in the model first. That is, that would be model 1 in this case, although in this case we're calling it the alternate or the null hypothesis. So that's our 134.14 and 0.96. We see the p-values. And the second model we see here is the one with both adverts and AirPlay. And we see that those are now both in here. And the nice thing is that when we look over here to see how the models are different, we see that our F change is 156.572, depending on H1 versus H0, and that gives us a p-value of less than 0.001. Furthermore, we get the two different F ratios for each model. Remember, this F change isn't the change we see in F ratios of the model. It's the F ratio of the R squared change. So just remember that small distinction. Okay, so that's all we need to do in order to do linear regression and multiple regression. What we've seen, we've done sales depending on adverts and airplay, and we see we get our beta coefficients are 41,000, and adverts add 0.087 for each ad, and the airplay adds 3.589 for each time that the song is played on the radio. Okay, let's move into SPSS and do this same thing. Okay, so if we open up the SPSS file, it's called record sales multi.sav, and it should look like this. Now, it should be reasonably easy to do a linear regression again, but this time using multiple predictors. So we simply go up to Analyze, scroll down to Regression, pick Linear. So what we're going to do is we're going to select as our dependent variable record sales. And what we're going to do is we're going to do our regression in a hierarchical manner. That means I'm going to do a first regression, that's block 1, using only budget. And that's what we did last time. Then into this block, I'm going to add a next block. The next block I'm going to do is going to be using advertising budget and number of plays on the radio. Remember, I'm selecting a method of enter again instead of the forward, backward, or stepwise other methods. So we can click on these different options of statistics, see if we want anything else. I'm going to select here R squared change, and that's the only thing I'm going to select at this time. Okay, so we can run this output. Here we go. Now, if I look to see what we get, I get a model summary that's got both model 1, and model 1 here shows my predictors of only advertising budget, and I get an R squared of 0.335, and a p-value down here of 0.000. Remember, our F ratio was 99.587. So these numbers are all the same thing we just saw in JASP. And remember our beta coefficients. Again, same thing from our first model, which only includes advertising budget. It's 134.14. However, in our second model, which has advertising budget and number of plays, that's model number 2 here, now we have an R value of 0.793, R squared value of 0.629, and that gives us an R squared change, now again, 0.295. Interestingly, what we do is we see an F ratio of that change. It's the same thing we saw in JASP, and we get a significance value of less than 0.001. Now, remember, it says significant F change 0.000. I can double click on this, and I can actually hover over and select to see what that actual value is, which is 8.09 times 10 to the negative 27. Okay. And we see for model 2, our regression equation is significant, F ratio of 167.203, and a significance of less than 0.001. And this is what we're going to use to report whether or not our regression model is significant. And here's our beta coefficients. So 41,000 record sales. Remember, these are record sales in thousands, so 41.124 thousand. And for each increase in advertising budget, thousands of dollars, we get an increase in sales of 0.087. And for each number of plays of radio plays on the week, we get an increase in sales of 3.589 in thousands. All right. So that's it. That's the easy way to do it in SPSS. Let's finally go back and do this thing in R. So if I open up R, what we see is here's where we had left off last time. We had done correlations, and remember we had done a simple model here of our regression model was a linear model of height in inches as a function of shoe size. So we're going to do something different. We need to be using our record sales data, so we need to import that first. So the first thing I'm going to do is click on import our data set here from text. I'm going to open up the appropriate file. That's record sales multi.csv. I'm going to call it just record sales. I'm going to give it heading yes, and this looks good to me. So import that. What we see is our data comes in. It looks like it did in SPSS and in JASP. And now what we're going to do is we're going to run some analysis on it. So if I just take this part, I'm going to copy it and paste it back down here. And the things I don't need are any of this correlation stuff because I'm just going to be doing a regression. Now, we're going to do a couple of different models here. So again, let's do the first model. So the first thing I'm going to do is I'm going to attach my record sales into my data frame. Okay. And then we're going to run a regression model of linear model LM sales as a function of, it's called what? Adverts. And my second variable is going to be called airplay. Okay. So, adverts. And then we can run that, look at that regression model. So I'm going to call this MReg model for multiple regression model. And I'm going to summarize it, and I'm going to give it a ANOVA of that. So that should be the exact same thing as we saw for our simple regression that we saw in JASP and SPSS. So if I run that, see the values that I get out. We see our intercept is 1.341 times 10 to the 2. So this isn't very friendly looking. So what I'm going to do is add one more command in here. Now, it doesn't have to be run every time, so I'm just going to run it outside of my list of commands. It's options scipen equals 999. What this is going to do is it's just going to tell it not to use scientific notation and to give me better numbers than this, what it looks like. So I'm just going to run that command using Control-Enter, and I'm just going to run this whole set again so I get nicer looking numbers. So here we have our intercept is 134.13 and our effective adverts is 0.096. Exactly the same thing as we saw in the previous two programs. And then we also get an F ratio of 99.587. Okay, now let's do the multiple regression version of this. Very easy. So I'm just going to copy this line here and put it in. And now I'm just going to call it multiple regression 2 model. And that's going to be sales as a function of adverts plus airplay. So now that's adding a second variable in. And the way that R does it by default is by using the enter method by default. You have to tell it if you want to use a stepwise type of method, but I'm not going to go into that because I don't think it's a good way to go unless you've got a really, really good reason for it. So then what we're going to do is we're going to display all of the models and run ANOVAs on them. So it'll be the same thing. I'll copy those 3 lines, but I'm going to do it for MReg2.model, summary MReg2.model, and ANOVA MReg2.model. Now, if I run all of this, what we see is, again, we get a new object up here called MReg2, so multiple regression 2 model. And we can see here that now, again, we've got our beta coefficients that gives us when I do a summary. And our summary shows us that it's 41.12, 0.086, and our airplay is 3.58. Again, and these all give us values that are significant. These p-values here just tell us that our coefficients are significantly different than 0. And down here, when we look, we see each of these predictors, we see if they are significant predictors, and we see that they are in this case. So finally, what we did see is we've got an R squared of 6.293. So that's the same value that we saw in previous programs. Okay, so the last thing, if we want to compare these models like we did in SPSS and JASP, we need to do one more step here. And what we're going to do is use this command again, this ANOVA. And we're going to run an ANOVA of mreg.model, comma, mreg2.model. So what we're doing is this is comparing the two models using analysis of variance. Now, I don't need to run everything because those two models exist. All I need to do is hit Control and Enter to get that. And what we see is we have an F ratio that is exactly the same as what we saw in JASP and in SPSS, telling us that the F ratio of the change in R squared is significant, and the F ratio is 156.57. Okay, so that's a fast burn through on regression again and multiple regression and how you compare the different models as you build them up. We're going to get into how to diagnose your models in the next video. Stick around.